Hello students, welcome to our new course Computer Networks 20CS 501. A computer network is a group of devices connected with each other through a transmission medium such as wires or cables. And these devices can be computers, printers, scanners, fax machines, etc. Did you know that January 1, 1983 is considered the official birthday of Internet? A new communication protocol was established and it was called Transfer Control Protocol Internet Protocol TCP/IP. This allowed different kinds of computers on different networks to talk with each other. Now, to share information, we need communication. This sharing can be done remotely or locally. Now, tele is a Greek word for the English word far, hence the word telecommunication, which includes other terms like telephony, telegraphy, and television, and they all refer to distant communication. The information delivered in any format that is accepted by the people who are generating and consuming the information is referred to as data. So, data communications are the transmission of data between two devices via a wire connection or other type of transmission media. The communicating devices must be a part of a communication system composed of a mix of hardware and software for data communications to take place. Four essential characteristics determine the effectiveness of a data communication system. First one is delivery. Data delivery to the correct destination must be ensured by the system. Only the designated device or the user must get the data, and only that device or the user. The second characteristic is accuracy. The data must be accurately sent to the system. The data that has been tampered with during the transmission and is not restored is useless. Timely delivery of data is required from the system. Late delivery is meaningless. When it comes to video and audio, timely delivery means sending the data as soon as it is created in the same order and without any noticeable delay. This kind of communication is known as real-time transmission. Jitter refers to the variation in the packet arrival time. It is the uneven delay in the delivery of the audio or video packets. For example, let us assume that the video packets are sent every 30 milliseconds. If some of the packets arrive with a 30 milliseconds delay and others with a 40 milliseconds delay, an uneven quality of the video is the result. Let us look at this diagram. Here we can see in the first part of the diagram, all the vehicles are moving with an even or equal delay. But in the second half of the diagram, we can see some vehicles are moving with an uneven delay, and it will cause an uneven quality of the video. Now let us see the different components of data communication network. For data communication network, we need two devices. Now, these two devices want to send a message from one device to another device. Now, if these two devices want to send a message, they need to follow a set of rules or a protocol. So now here we can see for a data communication, we need a sender, then we need a receiver, then we need a medium, and this medium could be air here, and when we have a sender, receiver and a medium, we are able to send a message. But at the same time, both the sender and the receiver will have to follow a set of rules or the protocol so that both the sender and the receiver can work in the right way. So here we can see the five components of data communication network. So five components are sender, receiver, data, medium, and protocol. Here we have one more representation of the components of data communication. So here we have a sender, and there is a medium, and there is a receiver, and the sender sends the message through the medium to the receiver. The sender and the receiver, both of them follow a set of rules which is called the protocol. So both the sender and the receiver will have to follow the protocol so that the communication could be smooth. Now let's look at the different modes of transmission. The first mode is our simplex mode. In simplex mode, the entire capacity of the channel is used to send the data only in one direction. Here we can see the example of a mainframe which only uses the entire channel only to send the data. It never uses the channel to receive a data. Another example is our keyboards and our traditional monitors. The keyboard can only introduce input and the monitor can only accept the output. The next mode of transmission is half duplex. Here each station both can transmit and receive, but not at the same time. When one device is sending, the other device can only receive, and vice versa. The entire capacity of the channel is taken over by whichever of the two devices is transmitting at that time. A very good example is our walkie-talkies. The next mode of transmission is full duplex mode. Both stations can transmit and receive simultaneously. The signals going in one direction share the capacity of the link with signals going in the other direction. Telephone network is a very good example. Here, both can talk and listen at the same time.